Okay, so welcome to Unit 2, Homework 1 and part of 3, which has to do with linear modeling. So we'll be doing two types of modeling, linear and exponential. There is not a formula sheet for this unit, so you will be expected to know the two formulas that I'm going to present shortly. But first of all, let's start off with kind of a warm-up here. You want to purchase tickets to see your favorite artist in concert. You have $24. You're going to do a weekly budget, add $5 aside, and how quickly will it take you to get $180? Will you have enough in 4, 16, 24, etc.? And will you have enough at that 8-month period? So you could probably solve this on your own. Just take 24, add 5 repeatedly until you got to your 180. Or you could just start taking the 180, subtract. There are lots of ways to do it, but what we're going to discuss then is a more formal approach to this, because what if instead it was a $580 concert, or we wanted to know what happens in 20 years or something to that effect. So what we're going to do is first think about what this PO represents, which is right here. Now, PO is going to be the amount you start with. That's the amount in your bank account at time 0. So it says here, let P of N, this is a subscript N, represent the money you have after N weeks. So P of 0 represents your starting because it's been 0 weeks. So at that point, this PO would be considered your initial amount. So you're starting with $24 in the account. So then P1 would be the amount after 1 week. So P1 would be total amount after 1 week. So then what would P4 represent? Total amount after 4 weeks. Okay, so let's think about this for a minute. We're starting with $24. After 1 week, we have in that bank account the $24, and we just added 5. So how much do we have? 29. Okay, and then after 2 weeks, let's think about what happens. We have our $24 and we've added 5 twice, or taken that 29 that we just had and added 5 to it to get 34. And then if we keep going, we're taking our 24, and now we have 3 weeks that have passed. So 5, 5, 5, or taking that previous 34 and added 5 to get 39. Same with the next one. We can either say, okay, it's going to be 39 plus 5, or that 24 plus 5 4 times. So what we come up with now is $44. Okay, so we have the first part of the question. How much money will you have in 4 weeks? You want to continue this for 16, for 24, and so forth. It may take you a little bit of time. So instead, we have this idea of a recursive formula. So over here, we had 29 was this value plus 5. Then the next one was 29 plus 5. Then it was 34 plus 5, and we kept adding to the previous value. So for this recursive value, what we did is we took any PN at any point, so week 4, week 3, what have you, was equal to the previous week plus $5. So that's our recursive formula. So what that P of N represents is week 4, for example. Then P of N minus 1 is week 3. So you took week 3, added 5. All right. Now the thing about a recursive formula is I have to know the previous term. So in this case, P of N minus 1 is your previous term. And if you don't know it, it's not as helpful. Because if I'm looking for week 52, I would have to have week 51, which means week 50, which means I'm writing them all out. So it works really well if you have a small amount, like 4 weeks, we can add 5 every time. If we want a bigger one though, let's come over and look at what we did. Over here, the initial value was 24. And then we took 24 and added 5 one time for week 1. For week 2, we took 24 and added 5 2 times. 1, 2, because there were 2 weeks. Week 3, we added 5 3 times for 3 weeks. 1, 2, 3. And for week 4, we added 5 4 times. 1, 2, 3, 4. So this number represents N, which is the number of weeks we're saving in this case. So what this means is that at any point in time, I can get a PN, such as the 52nd week, for example, by taking that initial value and adding 5, the amount of weeks it took. So that was my initial, and that was my number of weeks. So now the question is, will I have enough money to purchase the ticket in 8 months? And the other part was, how much will we have at 16, 24, etc. So using that explicit formula, we can get P of 4, and hopefully it'll match exactly with what we did earlier, because we should have $44 if we do it this way. All right, so I'm going to come over here, and P of 4 should be equal to 24 plus 5 4 times, which is $44. So that's good news. The next part of the question asked us for P of 16. Do you think we'll have enough money at this point? So it's 24 plus 5 times 16, which gives me $104, but I didn't have to go back through all of them. Then if I do P of 24, that's 24 plus 5 times 24. So that's my number of weeks. And I come up with $144. And then finally, 8 months. We're going to say 8 months is 32 weeks, 4 standard weeks in a month. And we're going to figure out, does he have enough? And the answer is he has $184. So he has exactly what he needs to be able to purchase the tickets in 8 months. Okay. And again, I got 32 because we're going to use the idea that 1 month is 4 weeks, going back to that dimensional analysis. So roughly 32 weeks to save. And if there's an extra week, he just has a little bit more and he's nice and saved up. Okay, so we're going to take this idea and make it a little more formal and call it linear growth. So with linear growth, we're going to take some initial quantity, PO, and to tell it's linear, it's growing by adding or subtracting the same quantity every time. So for growth, you're adding some set amount D. Okay, repeated addition and after n time periods, and that's going to be given by 2 different formulas. So the first one in general is this Pn equals Pn minus 1, plus we're going to call that difference D. So up here with the recursive, it was Pn equals the previous plus 5, because 5 was the amount we're adding. So that's what we're going to do here as well. So Pn is the amount after n weeks. And then P of n minus 1 is the previous amount. And it doesn't have to be weeks, it can be anything. It could be years, any of that. And then D is that growth rate. So D is that common difference or growth rate. So for our explicit formula, it was at any point in time, the initial value plus our D times N. So at any point in time, If you take the initial value and add D times N, then you get your explicit formula. So PO is now your initial value. All right, and D is that common difference. So you're adding or subtracting it, and N is your time. And it could be years, it could be days, it just could be any time period you're measuring in. So I keep mentioning common difference. That D is called the common difference, or the amount you're adding every time. Okay. All right, so looking at linear functions as a whole, a linear growth function is one that keeps growing, but it still looks like a straight line, which is your initial linear function that you started out with. So when I'm looking at a linear function, the basic formula is y equals mx plus b, right? And m is your slope, and b is your y-intercept, which is where x is 0, or your initial value. Same idea, p of n is d n plus that PO. But they're very similar in that your B and your PO are both where you start, and your D and your M are both your slope. Okay. So then if we review graphing, when you had a y equals mx plus b, okay, say for example, you had y equals 2x plus 1. Where you started was at that 1 or 0 comma b, and then you went up by the slope, 1, 2 over 1, 1, 2 over 1, and drew a line. That's the exact thing for linear growth, just now this point is your initial value, and this up and over is now d, and it's now the function Pn equals Po plus Dn. But very, very similar, right? So D is still the increase or the slope. PO is that initial value that you would start with, and we would continue to graph it the same way you're used to. Okay. Then when we do find the equation of a line, we're going to first give two definitions here. M is our slope when I'm doing a general linear function, and x1, y1 is just some point on the line. Could be anywhere. It could be right here. It could be up here. It's just a point on the line. Okay. So with that in mind, the slope-intercept form is the one I've already mentioned a couple times. It's y equals mx plus b, or p of n equals po plus dn. Now the other one is point slope, and it's a little bit easier to do if you have a point and a slope. And what you fill in is you fill in your y1 and your x1 with the point up here, and then you fill in your slope, and you would leave the x and y, and then you have a general format. For the first one, you fill in your m and your b, and you leave your y and your x out. Okay. So what we've been looking at is this slope-intercept is your explicit form. But the other one just may come in handy, as you'll see later. So a little bit of review here. So for this review, calculating slope. Slope is the same thing as your common difference. So we're going to start with 2 points. Those 2 points would be x1, y1, just representing a point on the line, and x2, y2, which is just another point on the line. So the formula for slope, this is another one you would want to remember if you don't know it, is that m is equal to the difference of the y values, and it doesn't matter the order, over the difference of the x values. And what does matter is that the 2's line up, so the second point, or just line up which point you have together. So this represents 1 point. This represents the other point. And then y is on top, x is on bottom. But you could also do y2 minus y1, x2 minus x1. So you could also write it like this. Just as long as you keep your points straight. And the idea is it's how far you rise over how far you run. Rise, run. All right, so for example, say you want to find the slope of a line through the points 2, 8, and 5, 12. Okay, in that case, my 2 y values would go on top, so 8 and 12. And the order you subtract them is up to you. So I'm going to do 12 minus 8 just to steer away from some negatives. And then on the bottom, you would have your x's, but they have to go in the same order. So since 12 went first, 5 has to go first. So I'm going to do over 5 minus 2, and I get a slope of 4/3. So what that represents is your slope, oh, gee, goodness, which is also your common difference. So you go up 4 over 3, and that would form that line. Okay, then moving ahead, if we want to write the equation of the line given slope and y-intercept, meaning we're given the initial value. So on this one, okay, say we're told the common difference is 7, meaning we're adding 7 every time. And the initial value, where we're starting, is 8. Write the equation. Okay, let's go back to sequences real quick. So I am starting with 8, and then I'm adding 7 every time. So 15, 22, 29. So I know in my head what that's going to look like. Now we're just trying to put it into a formula. So the formula reads P of n is equal to the initial value plus dn. Okay, so if I follow that, P of n is equal to the initial value of 8 plus 7 times n. Well, at time 0, I'm going to get 8, which checks out. At P of 2, I should get 22, which I do. So in this case, this is 0, 1, 2, 3, etc. So I was just checking a few points because we know what this should look like, and are we actually getting the right answer, meaning it gives us back what we were looking for. So that is our answer. Okay. And then finally, the whole thing is write the equation of the line given 2 points. So say this time you're given x1, y1, and x2, y2, and you need to write the whole thing from the 2 points. Okay. So say, for example, you have the point 5, -8, and 2, 4. Okay. Very first item we want to do is find the slope. Okay. So we're going to start with that. So I'm going to do 4 plus 8, the minus canceled, over 2 minus 5. So I am getting a slope of 12 over -3, which is -4. So that's my slope, -4, which is my m. Then I'm coming over here, and now you use either equation. So use an equation that you were provided, and it can be either the y, I don't know why this is writing funky. It can be either the y minus y1 equals mx minus x1, or it can be y equals mx plus b. It truly doesn't matter which one, you pick the one you want. So I'm going to do the first one first. So if I use y minus y1 equals mx minus x1, what I'm going to do with that is say y minus y1. Now what I use for y1? This guy. And it doesn't matter which set of points you use, you will get the same answer for either one. I'm just using the one without a negative. Equals -4x minus x1, which is 2. So just stick to one point, and you'll get the same answer either way. So now I'm going to finish this off. That'll be -4x plus 8. Y minus 4 equals, add the 4. So I come up with y equals -4x plus 12 as my answer. And if you want to try it with the other point, you should get the exact same answer. Now, if I'm going to try it with the other one, which is the y equals mx plus b, I could do that too. So what I'm going to do with that is y equals mx plus, and I need b. So let's think back for a second. I don't have b. Okay. So I'm doing y equals mx plus b. Okay. So I'm going to pick a point again and plug it in for x and y and solve for b. So let's pick the 2, 4 again, just because I already used it once. I don't want the negatives, but it really doesn't matter. So I get 4 equals -4 for m, 2 plus b. So that gives me 4 equals -8 plus b. Add the 8 over, and I get that 12 equals b, and now I plug in the m and the b, giving me y equals -4x plus 12. It does not matter what you use, they are going to be the exact same. All right, and then finishing off this idea, linear growth was where you're going up, as I mentioned, and you're adding d units. Linear decay is where you're decreasing. So these lines are going to have negative slopes and look like that. So your recursive and explicit formula are not two more that you have to memorize. All we're doing is making d negative. So the recursive formula before was Pn equals Pn minus 1 plus d. What we're going to do is say d is negative, so we're going to subtract it. And if you weren't sure, the d will come out negative if it's decay. It'll come out positive if it's growth, so it'll work out. And then over here, it was P of n equals PO plus dn. We're going to do the same thing. We're just going to erase that and make it a minus. Okay. So again, you don't get a formula sheet. These you do want to know, but decay means you're going down. So if you're growing, your slope is going to be positive. It's going to give you a nice positive growth. If you're decaying, it's going to be negative, and it's going to be going downward. All right, and that's where the notes portion ends. And then there are several practice problems to try.